Good day, everyone, and thank you for joining us on this webinar. Today's topic will be Fusion 360 cam turning. My name is Irshad Hanif. I'm an application engineer with Micrographics. In a few seconds, we will begin. All right, today's agenda. We're going to discuss a little bit about myself, who I am, what I do, and what Micrographics does. Then I'm going to highlight the purpose of this webinar and tell you exactly what we're trying to explain or what we're trying to educate people about with regards to Fusion 360's CAM workspace, specifically the Turning workspace. Then we're going to discuss in detail the CAM workspace, what it is and what it's all about, where can you find it. Then we're going to discuss three major topics about Fusion 360 CAM, and that are setup, toolpaths, and tools. Okay, of course, once you have all of those things, you will be able to generate Gcodes and, of course, modify them to your liking or to what the CNC machine's requirements are. And at the end of this, we will have a live demo of putting all those topics together to show you what it looks like in practice in Fusion 360. Okay, at the end, we will have a Q&A session where everyone who's joined this webinar will be able to ask some questions. And we have people available to answer them, or I can answer them myself. If you're more than welcome to type these questions in as the webinar goes along, and I will try and answer them when I see them in the chat box. So if you look at your meeting, your TeamViewer meeting box on the bottom right, there is a chat option available where you can enter any questions you may have as I go along. But like I said, we do leave a small section at the end of about 5 to 10 minutes where you can ask your questions, and we will pause and discuss them. All right, so without further ado, about me, my name is Irshad Hanif. I'm an application engineer with Micrographics. I have approximately 8 years of experience coming from a mechanical engineering background, and my primary areas of expertise are in AutoCAD, Fusion 360, Inventor, and of course I deal with multiple facets of the software. So I dabble with a little bit of CAM, finite element methods, design and modeling, as well as PDM. So you're looking at things like Bolt and other such software. Okay, I'm also an Autodesk certified professional for Inventor and AutoCAD. So I think over the years I should be able to, or I have gained enough experience on the topics at hand. Okay, the purpose of this webinar. What are we trying to say, or what are we going to discuss? Well, we want to outline the features and capabilities of Fusion 360 cam turning. What can it do, what can't it do, and whether you need it or not. So some people are going into the CAM workspace for this first time. They're interested in CNC. They're looking to what software they can use, but they're not sure whether Fusion 360 is right for them. Well, we aim to answer that here. Okay. We also want to introduce first-time CAM users to the Turning workspace. So you already have Fusion. You've been using it, for example, for milling, but you're not familiar with Turning, or maybe you've been using Fusion 360 for modeling, but you're not familiar with any part of the CAM workspace at all, and you're keen to learn. Well, here we'll be discussing the basics of it, what it's all about. Okay. We also want to illustrate the benefits of using a CAM package. As compared to doing it with a third-party CAM package. Remember, some companies, they have a workflow where they would be doing their models in a program like Fusion, but because of legacy issues or current workflow, they might export that CAD data to a third-party package to do their CAM, not realizing that you have a lot more advantages if you use Fusion 360 with its built-in CAM capabilities. Okay. We also want to do a physical demonstration. Like I said, some people are very new to this, so they don't know how it looks or how it should look. And or maybe some people have been doing it all along, but they may be improperly trained, so they can get a better of idea of how it's done. And then we want to discuss or we want to outline rather the best practices for cam turning. That goes hand in hand with the previous point about people just looking for quick tips and better advice for what they're currently doing. And then we'll highlight specific features of Fusion 360, how it can make it easier to modify your G code or use additional additive manufacturing enhancements that are available using cloud credits. So we will discuss all of that. Okay, so let's jump straight into it. The Fusion 360 CAM workspace. Okay, so as you know, Fusion 360 separates all its tasks in what's called workspaces. So you would start off by designing your model in the design workspace. Okay, you would draw up whatever the part is, and when you're ready, you will simply switch the workspace and it'll allow you to change the ribbon up top to get all the options you need for example, rendering or animation or doing drawings. In this case, we will change that workspace to the manufacturer workspace. Okay, so you can import your model from a third-party software. So perhaps you're getting client drawn models in stuff like SolidWorks or Inventor. You can import that model and simply jump straight to the manufacturer workspace, or you can draw your model in the design workspace and immediately jump to the manufacturer workspace. It's really up to you. Okay. The manufacturer workspace is separated into different types of CNC operations. So you can see at the top here, you have your main manufacturer workspace with all the tools, but you can switch between which type of CNC operations you want to do, whether it's milling, turning, and fabrication for plasma and laser cutting, right? There are also inspection for probing and additive manufacturing, but that won't be talked about too much in this webinar. The main types of CNC are going to be milling, turning, and fabrication. Okay. In this workspace, there are three basic steps that you need before you can successfully create a CNC program. And those steps are, you're going to create a setup to define the stock materials and origin points and etc. etc. You're going to create or pick your tools if you have them created already, and you're going to generate tool parts. So in that particular setup, you need to generate parts which the tool that you're using will go in and cut and clear all the excess material away. And lastly, once you have all the material cleared away and you're happy with the finished product, you can simulate and send to the post processor, which will generate your G code for you. Okay. The next thing we're going to or the first thing we're going to discuss of those three steps is the CAM turning setup. Here we will define our stock material, our stock size, our axes and orientations, our origin point, the chuck reference, and the areas to avoid. So if you look on the right in the image here, you can see that the translucent yellow bit is basically defining the solid block of steel or plastic or whatever material we're building that is going to we're going to start with, and we're going to clear as much material as we can to get the shape we want using different types of tool parts. Of course, the CNC machine doesn't know anything about the starting stock. So you've got to tell it, okay, which way is the Z direction, which way is the X, which way is the Y. You've got to tell it where on the model is 0, 0, 0, meaning your origin point. Again, you'll have all these options to flip them, change them around. You've also got to tell it how much bigger than your model that you've drawn is the stock. Meaning you can see here that the translucent yellow bit sticks out a little bit more than the model. So it's not the exact same size. You've got to mill it down a bit to get to that the outermost area of your model, and then start milling inward, inward, inward until you clear most of the material and get the shape that you want. Okay. In this process, we can also set world coordinate system offsets, and as well as give our program a program a name, a number, and add in a comment for a description. Remember, some controllers only accept numbers for their program names. And I think they have a limit of about 6 or 7 digits. So we've got to be wary of all that and give the information to the machine correctly. Okay. The next step is creating toolpaths. Now that we've defined what our starting material is, we can define how our tools go in and clear away that material. All right. With turning, there are three basic starting operations that we will need to basically outline, and that would be your initial facing to uniformly take off the axis. So if you look at where my cursor is here, the first bit you'll have to shave off the front to give it that smooth flat finish that you want, and that would also get your stock in the right size and stop at the model. The next important toolpath that you'll be using will be a roughing profile. So you'll see the middle section here with all these blue lines. That's basically to clear out a majority of the excess material, not necessarily everything, because there might be finer details that you need to do later, but clear out as much as you can as quickly as possible with a really capable tool. Okay, and that will be a roughing strategy. And lastly, you would do a finishing. So once you've got the shape that you need, you would go in and use a finishing tool to get the tolerances and the finish you want. You probably have to do it at different speeds with a different type of tool. And you're generally going to go slower here because you want to get a nice, smooth, perfect finish without any bumps and grazes. Of course, in between roughing and finishing, there could be many other types of strategies that you would put in there. For example, if you look at the middle circle here, we'd want to cut out that groove. Obviously, our roughing profile, you can see it doesn't get quite in there, so you have to use a grooving tool to go in there, cut out that groove, and then come and do your finishing to get the perfect finish. Other types of strategies would be perhaps a threading. So if you want to add a thread on one of these sections, you can go and use a threading tool and create a thread according to what size and what pitch you want. Okay, the toolpaths will be added to the current active setup, meaning that when we created the setup from the previous slide, that becomes the active setup, and all toolpaths you can see on your browser tree on your left here get added to that active setup, and we can generate a Gcode for that setup. Sorry. Yes, we can generate a Gcode for that setup. Okay. It is best practice to simulate after each toolpath just to ensure that you're getting the correct result. So we want to look at what the tool is doing, where it is going. Remember, the simulation environment also has a collision avoidance and speed analysis tool where you can look at what it's doing, what position is it at any given time during the toolpath. Okay. So with your toolpaths, each toolpath strategy you select will provide you with a dialog box that requires various inputs for you to successfully generate a safe toolpath. Okay, these will include things like, okay, which tool should the machine use? Which way should you machine? So obviously, if you've defined the front and your back in your model or in your setup, you can say, I want the tool to move from the back to the front or from the front to the back and continuously clear out material in that manner. Okay, you can also define your clearance distances. So the radius at which the tool must be away from the stock material in order for it to rapidly move to ensure that it's quite safe and doesn't collide with anything. We can also define our speeds and feeds if you wish to override the tool setting. So what does that mean? Generally, when you're creating your tool, and we will come to this in the following slides, you would have the option to tell Fusion what speeds and feeds that tool should operate at. Generally, the manufacturer of that tool would give you a rough idea of how capable it is and what are safe operating speeds. However, you can override these settings per operation. So if you're doing a facing operation and you know this tool can handle a much higher speed to go and face off really quickly, you can override it in this TwoPart Generation menu. Okay, you can cycle through the tabs, or rather you should cycle through the tabs to input the various data, and you've got to go through them one by one. It's best practice not to skip anything, because there will be some important information that will cause your entire toolpath to be generated incorrectly and cause major problems, often resulting in costly tool damage and collisions, or perhaps damaging your part altogether, and you don't want that. Okay. Then the last point I put there is something about rest machining. So I've often been asked, what is rest machining? Well, rest machining is a process where your current toolpath that you're generating will take into account previous operations or previous cuts with a tool. So that means it knows what's already been cleared and will only cut based on that. That will prevent air cutting. So air cutting is when it goes and cuts basically nothing, because it doesn't know that the previous operation had already cleared away that material. Okay, so let's discuss cam turning tools. So in the tool manager library in Fusion 360, you can see here we've got our tool library open, and this is a preview of what it looks like. You'll be able to have a list of all tools available to you. Fusion 360 does contain a library of tools, standard tools that you'll be able to use. But if you want to create your own tools, you will be able to create your own from scratch again. However, the best practice is to copy these standard tools. You can see here they've got standard tools, standard holders for different types, imperial and metric type of tools. The best practice is to copy them to a library of your own choice and create your tools for your machines. Okay, the tool library has standard tools categorized by one type. So it can either be a milling, drilling, turning, grooving, threading, etc. And size. So it can either be a 5 mil or a 10 mil or a 2.5 inch or etc. If you look on the right hand side of our tool library, you will see a little filter that helps us make this list look less intimidating and less chaotic, so that we can find the tool that we want easily. So for example, you'll be able to click on, I want a milling tool that's 5 mil and etc. Okay, so you can filter out multiple things. Okay, there are also standard holders available. So if you look at our list in Fusion 360, we have sample holders. It's important to basically define your holder, because these can also create collisions. If you have a really thick rimmed holder that has a wide diameter, these things can collide in certain circumstances and cause, again, great damage to your tool, to your machine, and to your part. Okay. Like we've said, the filter allows you to refine your search. The best workflow is to create your own library of tools. So you will see that I have a preview of what it looks like to create a tool. You'll be able to define all aspects or all geometry of a basic tool. So for example, here is a turning cutting tool. We can define the holder geometry, basically how wide, how long, and what angle is it pointed at, whether it's a left-hand tool, whether it's a right-hand tool, etc. Okay. Again, I'm going to stress this one more time. Best practice to copy an existing standard tool and simply modify the dimensions rather than to create it from scratch, because there might be some important data that you've missed or that you've entered incorrectly that will cause problems for you later on. And I will show you exactly how to do that when we get to the live demo. Okay, and the last section we're going on to is cam turning, Gcodes, and modification. So once your setup and toolpaths are done, and you're happy with, you've simulated, you're happy with how the machine is clearing away all the material, and you're happy with the final end result, you obviously want to get this Gcode to be understood by your CNC machine, right? You can simply generate a Gcode from for your setup using a simple generate or post process button on Fusion 360. Okay, you'll be greeted with the dialog box that you see on the right. Okay, and this will allow you to do a lot of things. First, you'll see on the left hand side, it will allow you to give a name number, like we said in the setup, but it's just redone here, so you can rename your program. It will allow you to choose a post processor for the type of machine that you're using. So in this case, I'm using a Fanuc post processor, and you can arrange or filter these things the way you want it to choose which one you want. You can give it an extension, but again, this will be governed by the type of processor that you choose. So some use TXT, some use .tap, some use .nc. It really depends on the machine. Right? You can also define the output folder, so where you want to save this, so you know where to find it when it's done. And if you look on the right-hand side, you will find post processor properties, or rather just it says post properties. This will allow you to quickly change certain things that are exclusive to that post processor. So Fanuc turning, for example, will allow you certain options. It will allow you to um, uh, enter a G53 home position X. It will allow you to preload the tool or allow you to modify the line numbers. Sometimes line numbers, a simple thing like line numbers can be very problematic. For example, you might have N1 to N500 or N1020, whatever. And some machines are not the newest of machines, and they might have a limit for how long the line of code can be. And a simple thing like the 9 number in front having more digits than it can handle can really bomb your machine and make it unreadable. So you can choose to use sequence numbers or not. You can also choose to write to list, allow safe retracts, etc., etc. We will go through what options you have in an example, but it exists in the generate NC program menu that you will click when you're ready to generate. Okay, you'll also see a tab there for operations, where you can select exactly which toolpaths you want to generate toolpaths for. Okay, we will take a look at modification settings in depth in the live demo. So don't worry too much about the right-hand side of the image. We will, because I cannot scroll obviously in the image that I've shown you. Okay, and with that, without further ado, it's time for a live demonstration. Okay, I'm just gonna start up my Fusion 360. Okay, so I have Fusion open and I have brought in a model that I have. It is a simple neck ring model, and you can see I am already in the manufacturer workspace. Now you'll notice that there are a lot of shapes. There's a tapered angle, there's some thread, and there's a sort of groove section in the middle. And of course, I want to get to a state where I can machine this. And of course, to machine this in our CAM turning workspace, we need to do the 3 steps, which is to create a setup, um, create our tools and toolpaths, and then send it off to a post processor to generate our Gcode. Okay, so before we begin, just a little note that you can see that I've modeled in our thread for this networking. It's a continuous thread from the end here to the end here. And in order to generate or in order to generate a setup successfully without any hassle, we would need a outer surface of that thread. Now, the fact that it's modeled makes this very difficult. So what I can do is I can go to my design workspace and I can simply edit my threads And so actually I can sort of, or rather maybe I should just go in and fill it down there. I will simply delete them. I would rather create, perhaps just for illustration purposes, a thread. Sorry, it's in create thread, and I'll create them here. I'll create it in one continuous feature, and I will not model them in so as to have a smooth surface. So it will have the indication of a thread, but not actually model it in. Now that that's done, I can move back to my manufacturer workspace, and we can start with the setup. So if you notice here, here's my setup folder. I do not currently have any setups generated. I will start this by clicking on the setup button. Alternatively, I can right click, and I can say new setup. You'll see that it will draw a translucent box around it, but obviously box is not what we're looking for in a turning operation. Now, mind you, I've actually just made a mistake. Can you guys spot the mistake? I sort of jumped the gun here and I did not change to my turning workspace. I'm just going to cancel that. You can see that the operation type is milling. We're going to cancel that. We're going to switch to our turning workspace, and you'll see that the ribbon changes to our turning operations, and now we can create that setup. Okay, it still draws that box, but when we change the operation type to turning or mill turn, we get a cylinder, which is more like what we want. At this stage, it automatically selects based on the way you drew the part, which is the front and which is back. So you can see that there's this green square here indicating where the chuck of our model sits, and the triad here indicating where our origin and where our starting or ending point is. So we choose that as the back and that is the front, which is what I want to do. So I can get a chamfer out there. We can do that. So you'll see that it's drawn a rough block around that. So let us define some critical things about our stock, namely, what is our axis? So if we look at this model, we can see that it's automatically identified the cylindrical axis as the Z axis, which is correct. And we can choose to select any other type of axis, for example, the Z and X, Z and Y, to change it if we were to. So for example, if I wanted to say that it was the Z axis and going that way, we can sort of flip it around and you'll see the chuck will move to the back. So if I do that, you can see we easily able to change our thing around. Alternatively, I can also flip which way is my X and which way is my Z. So generally, your machine will have your positive X axis going toward the part that's being turned. So it'll be like this. Remember that the arrow indicates the positive direction of the particular axis in question. So that way is positive Y, that way is positive X, and that way is positive Z. Okay, I can also choose where I want the origin point, which means the 000 point. For example, I can choose the model front or the stock front. What is the difference? Well, the stock front is if you have, let's say, 5 mils extra on the front, that's going to the stock front. I can also have my 00 there or my 00 there. It really depends where you want it. Or I can simply say that I want to select a point on here, and it will allow me to select where I want my 000. In this case, it'll be safe if I select my stock front as it was before. Okay. And so we have our origin, we have our truck location. So we're saying at the back. Of course, if you want to tell the machine that the chuck is actually somewhere up close to the front and we must only machine up until there, we can tell that. So we can say that, listen, here is my save Z reference, here's my chuck. So I'm going to go to the next tab, which is my stock part. And here we can define whether it's a fixed size cylinder, a fixed size tube or a relative size tube, or etc. etc. In this case, we're using a fixed size cylinder, and it detected from the diameter and it gave an appropriate size automatically. Fusion 360 is pretty smart like that, but if you want to give it a relative size tube, meaning that you know that your stock is 5 mils bigger than what you trying to machine, then you can do it in that way as well. So you can also give an offset in the front, and you can say, and the front side offset is, I know there's 3 mils at the front, you will see that it will do that. And remember, I'm using a tube, so it's hollowed out. You can define exactly how wide and narrow your tube is. So you can say the back side of the stock is here. In this case, I'm going to use a relative size or cylinder, which means it's a solid. There's no hole in there. And I will go at radial offset of 5, front side offset of 3, and a back side offset of perhaps 5. So you can see it's looking like so. Okay, and of course the last tab is your program number and your comment or your description. And like we said, we can add in a world coordinate system offset machine WCS if needed. Okay, now that we have our setup, okay, and we have defined our origin and our axes, we can also define here, like I said, our chuck. So it looks to be, as I see, too far back. We want to put it here somewhere, maybe. So maybe put it +10. Or I can perhaps say from solid, or I can say at the model back, which is means which will flip it around. In this case, I just want to say the stock back, like so. And I want to give it an offset of 10, which is why it's 10 from there. If I make that 0, you'll see that it goes right at the back of the stock. But I've added 5, remember, in my stock. Oh, so yeah, so I've added 5 on there, which means I want to make my chuck reference 5 over there, 5 mils inward. So that's what I've done when I've added my 10 mils. There we go. So that's quite easily understood, and we're able to customize just as we need it. Once we're happy with the stock setup, we can say okay, and our setup is done. Now we move on to the next part of the task, where we can generate our toolpath. So like I said, we will start off with a very simple facing operation to get rid of the front bit here, so that we can start clearing out our material. Here's our face operation. I'm going to click on facing, and you'll see that it gives us this dialog box that we discussed earlier on. It's going to ask us to select our tool, the orientation, etc., give our feeds and speeds. It will preload the data from the tool that you select, but you can go in and override it. It'll ask for geometry, clearance radiuses, number of passes, if you want to cut a little bit at a time, and it will ask you the linking and transitions. Okay, let's start from the very beginning. I'm going to choose a tool, and you will see it will take me straight to my tool library. But I'm going to use my filter to find a tool very quickly. I'm going to say that, hold on, I do not want a milling tool, I actually want a turning tool. And I want a general turning tool. Okay, and I want to search, remember, it will search wherever your cursor is selected on the left-hand side. So right now, it is selected all. So it is filtering from all of this list here. I want to search only in my metric sample tools. So I can search for a turning general tool. It doesn't find any. I can search for a tutorial metric. Let's just look in the library in general. Again, there we go. It's found something. It's found I can either choose a right hand or a left hand tool. Okay, so I'm going to choose a general right-hand tool with a 0.2 mil corner radius, or maybe if it's just for pacing, I will choose a slightly larger 0.8 mil radius. Okay, I can choose this tool as is, or I can copy this tool and paste it in one of my libraries. So if I have, for example, a new library with my machine, enter, I can paste it in here. And once that's done, I can now have the option to edit it. Remember, you cannot edit library tools because they are read-only. But once you've copied something to your library, and in this case, I will use the cloud library, you're more than welcome to use your own local library. But I would advise using the cloud so that other people can see the tools as well. We can edit the tool, and we will get the menu that we saw earlier on in the slides. So we can give it a product ID, a description, right-hand tool, my first tool. We can define the dimensions of your cutting tip, dimensions of your holder, whether it's a left-hand, right-hand tool, what type of clamping, etc., etc. Right? I'm going to leave all the data standard. This was just for illustration purposes to show you that you can modify and change every aspect of your tool. I'm going to accept, and you'll see that it will give you the tool number or description and your personal description that you've written. Okay, so I'm going to say select that tool. You'll see that it inputs our tool in here. I've just orientated the wrong way. Okay, now that you can see, it is going to start generating toolpath based on that. I can override my feeds and speeds if I want to, but I'm just going to go to the next tab. You'll see that since this is a facing operation, it's going to detect where the model starts and it knows where the stock starts, and it's going to clear all of that. You're going to tell it the clearance radii, meaning how far away from the part or the stock will it know that it can rapidly move. Okay, for example, the clearance area I can say is 8. So you can see that I can move safer, not too far away, so it doesn't have to move too far to rapidly move. Your passes, this will define how many or how deep each cut can be. So for example, in this case, you can see the part that is generated is wants to go in once and cut all of that 3 mil, I believe it is, 3 mil off the face of the stock. I can set it to choose multiple passes where I take 1 mil at a time. So you can see it does 1 mil, 1 mil, 1 mil, and that's your total of 3 mil taken away. Okay, I will leave it as such just so we can see what it does when we do a simulation. And you can set your tolerance and your compensation type to define where it is calculated, either in the computer or etc. All right, the last tab is for linking, and it defines your leads and transitions, so your lead-ins and lead-outs. You'll notice that the toolpath that's displayed here, the yellow, blue, and green lines, are color-coded. Yellow meaning areas where it is moving without cutting, blue meaning areas where it is moving and cutting, green meaning leading in and leading out areas. So these settings here define your leads and transitions. Okay, you can also have approach and retract distances. So you can say save C distance from your radii. You can also set up your linking. Generally, you wouldn't need to touch these, as these are very much for if you're a beginner. I would advise you don't make too many changes here because these can mess up your toolpaths. As it stands, we are good enough to cut as is, so let's go ahead and generate that and we can see how it looks. So you'll see that it has generated a toolpath for us called phase 1. We can use our simulate tool by either clicking on the ribbon, or we can right click and say simulate. It's important that we get into the habit of right clicking and simulating on the setup instead of the individual toolpath. That way all toolpaths are taken into account. So if you have multiple, it will take all of them into account as opposed to just one. Okay, you'll see that when we press play, it is shaving off 1 mil at a time in a facing operation of the front of our part, which is what we want basically. Right. The next type of toolpath we can do is a roughing strategy, just to clear out most of the material from the face, the front of the face to the end. So we can go in and say, right, I want to do a little roughing strategy or roughing profile, and I'm going to select a general tool, or I can, now remember here is where we're going to have a difference of opinion. Some people might want to start with a left hand tool and dig in and come in this way to get that shape right. Some people want to clear as much material as they want using the current tool to prevent tool change. I'm just going to use the current tool, see what it clears off, and then I'll switch to a left hand tool to clear off the other side. Okay, I will leave the, now you'll notice that the tabs look different. Okay, so you can see we've done a roughing profile, and it was quite different in terms of options from the face strategy dialog box. Okay, so you see we have all these different options. We have the model to choose the front and the back and which direction to move from. So we can choose, well, it's labeled quite clearly here. That's the front, that's the back, which is correct because that's where the chuck sits. You'll know that when we get to the passes, you can choose which way it moves, from front to back or back to front. We can look at the radii and clearances. So we can say, okay, the clearance, I'm going to, just for illustration purposes, put it to 8, just to show you that you can define all your radii or your movement radii. And again, to reiterate, we can change the direction from front to back or back to front. We can allow radial grooving, use can cycles, define the depths of cuts of our passes, so how much it cuts at a time. And we can define the cycle whether we want horizontal or vertical pass. If I hover over this, it should. So remember, horizontal defining the way it goes along or into the part as it cuts. So I will show you both. In fact, I will generate both and show you the difference between the two. And last, of course, as I said, the linking, where you can define the leads and transitions and the linking settings. I'm just going to say OK for now. And we can take a look at what it's done. So you can see we've used the horizontal cutting style, where it's going and taking long cuts off to shave off whatever it needs. And if I run a simulation on that, I can say simulate. Again, I've done it on the setup, so it will show me all tool parts, and I can switch to the next operation to show how it's going. I'm just going to speed it up a little bit. You can see it's shaved off the front at an angle, but of course, it's quite clever. It did not shave in where it couldn't go or where it would collide. So it's done as much as it could before the tool collides, and then we can come in with either a left-hand tool or a tool that's more angled to go in and cut. So I'm just going to go in and edit that to show you the other strategy where we can use the vertical passes, and it will generate vertical cuts like so. So now if we simulate, we will see. Let's take a look at what that does. You can see there that there's some collisions though. So I'll go back and I'll start that again, and I'll say stop on collision. Actually, no, I was wrong. There isn't. It's just, it looks like it, but it isn't. Okay, so it cuts as best it can. From there, I can do another roughing profile where I would change my tool either to a left-hand tool. So I'm going to look at my turning general, and I can use a left-hand tool or a sharper. Let's look at turning type. Okay, let's use a left-hand tool. We'll select that. So we're using something like that. And we can see now we have a sharper angle as well. And we're going to go in and cut the shape. Now I'm going to do a roughing, and I'm going to use rest machining. That way it knows what's previously cut from profile roughing 1. Okay, and I'm going to choose my model back and front. Actually, I'm going to leave it as is. I'm going to leave that to 8. I'm going to set either from front to back, from there to there. That's correct. In fact, actually, perhaps I should change this. I should go from here to here. So I'll go from back to front, and the style will be horizontal. Okay, so I'll generate this and let's see what it does. So we can see that it is now generating a TwoPart, and if I simulate that, you'll see now that it is generating and you'll see that it collided at the end. I told it to stop on collision. It collided because of that part on there. So perhaps maybe I should tell it to I will edit my tool. I'll use in a right hand tool, but a sharper right hand tool. So I'll look in my library, turning general. Oh, not that one. Let's look for a VNMT. VNMT right. There we go. That's the one. And we're going to generate from horizontal passes front to back. Let's see how that goes. Okay, so that looks better. I'm going to simulate. And of course, there's a little section here that we want to get rid of because that angle cannot reach in there. So what I can do is I will generate a third roughing profile, use that tool, or rather maybe use a different tool. And I will look at a turning tool, turning general tool, and a left hand. And here, what I can do is I can define that I only want a machine from here to here. So I will say I will select the front, and I will select the back, which is there. So it's only going to calculate from there to there and do its thing. I'm also going to turn on rest machining to know, so it knows what's already cut. And then I'm going to say that it must go from back to front. And you'll see that it takes away exactly what we need. So let's do a last simulation of what it needs to cut. And there we go. Our part is done. Okay. Now that we've got that done, the last thing we can do is add in a threading for these two faces here. I'm just going to show you an example with one as we are running out of time. We will use a threading tool. So I'm going to search my library and I'm going to use a turning tool. I know that it's a turning threading. It's going to be an OD thread, and I'll select that. OD threading should be like so. Oh, sorry, my apologies. I've clicked the wrong button. I meant to do a threading. That's why the tool was red. I was wondering what happened. I clicked grooving. My apologies there. I'm going to go to turning threading. I was wondering what was going on. And OD threading like so. I can choose any style that I want, but I'm going to go either something like that. Okay, and then I'm going to say if I needed to do threading on just that bit, how would it work and where will I go? So I will start maybe telling it as an example, which are the thread faces. It's that one. And our radii where our clearance areas are, our retraction policy, everything looks good. Let's just see what it does. So we can see that it's going into there and starting. So let's just simulate and see what that looks like. I'm going to simulate the entire thing. And you'll see that it starts from there and it goes in and cuts our thread as it does make a collision somewhere. Of course, that's because it's the wrong tool. The idea is we can go in and refine that. Because we're running out of time, I'm just gonna not fix that. We will learn how to fix that in training. But I'm gonna wrap this up and say, right, now that we have all the different tool parts, I'm going to generate all of this into a Gcode. So I can say generate, yes. And I can say NC program. You'll see that I'll be greeted by this window here. So it's just went to my other screen. And you'll see here that it is the window that we are familiar with from the slides. I'm going to use phonic turning, and I'm going to say, right, these are the options that I want. I have some added options in here to preserve rapid movement, high feed rate, etc., etc. I've got the option to use radius arcs instead of I, J, and K. I've got the option to not use sequence numbers or make the increment 5, or sorry, make the start sequence number 1 and make the increment 5, for example. Write machine settings or machine list, or write tool list. And I can choose exactly what operations. In this case, I want to choose all the operations, and when I'm ready, I can click post process. Okay, it's going to generate and say override, and just like that, my NC code is done. I can click view to view it, and it will show up in my NC code viewer. You'll see that I have my G code generated successfully. For all, it will tell me what operation it's doing, roughing, and finishing, etc., etc. And just like that, our G code is done. Okay, so now that our G code is done, we can always go back and edit exactly what we want, and we can give it another name. We can say 00, and we can make different changes and post it out. And immediately regenerate that. And you'll see that it's made the appropriate changes to our code. You can see that our line numbers are going in increments of 5 as we set it, and it's providing the name of the operation and the tool and speeds, G54, and doing everything that we need in one shot. And that was basically it. We have successfully generated a G code for our turning part. Okay, with that brings us to the end of the webinar, and I would like to close the session by asking if you guys have any questions or if you don't have any questions at this time, my contact details are up on the screen. My email address, you're welcome to email me or give me a call on one of those numbers. There is our office line there as well. You can phone directly into Micrographics and ask for me if you are curious about anything that you've seen today. So I'm going to leave the lines open and try and answer some questions if there are any. Okay, I see some people are. Okay, yes, you're welcome to take down my details. Yep, it's up on the screen there. Okay, great. I'm glad it was. Some comments are coming through um, saying the webinar was very helpful. I'm glad it was. Okay, so if we don't get any questions in the next minute, I will be ending off the session. And thank you again for joining us, Micrographics, on this webinar. And we look forward to seeing you again for our next one.